Okay, so this is section 7.9, and we talked about this, but let's just review it before we finish up the chapter. So string methods, remember methods are like our functions, but they're used in special scenarios. So remember we had this example. This is not a method, this is a function we're going to look at. So we create a string here called, and we give it the name stuff, and then we can apply type, we can apply dir to it, and that gives us some information about stuff. But anyway, the point here is this is the way we run this type function. We put type and then brackets and then something in it. But when we're working with methods, it looks different than that. So here's an example of a method. So here we have a string, same as before, and this time we assign it to this name, and then we can run the upper method, and notice we don't put word inside, we use this dot notation, so it's word dot upper. So when you're using this kind of dot notation, or when the function works like that, it doesn't, like, I don't think we can put word in here and it will run properly. The way you have to do it is you have to do word dot upper. So that's an example of a method. That is, upper is an example of a method. We say that upper is a method for word. Or we also say, since word is, of course, is a string, we say upper is a method for the string class. So any string you can use upper with, and you use it with the name of the string, and then dot, and then upper. Here's another example that we saw. Here we have banana, and we assign it to word, and then we have a find method, and we can put something in there, but we don't put word in there. So we are using the dot method. So we are using the dot notation. So find is a method. Now it doesn't mean that you can't put something in there, and we are putting something in there, and it's finding the first occurrence of A. So that would probably be 1, right? This would be 0, and this would be 1. Let's just check that. So 1. Okay, and this is another example. We have line is something here, some string, and then we apply the strip method. That takes away all the white space around here we go. Now, after we do that, then we're applying a print function. It's not a method, right? We don't have something dot print. We're just writing print and open brackets. So that's not a method. That's called just a regular function. Okay, we had some other examples there, and other examples here. We have lower method and starts with method. Here we can apply the dot twice, actually. So we're applying two methods here, two lines. So we start with line, and okay, I'm not actually sure which one gets done first. In this case, it doesn't make any difference, but it could make a difference depending on what we were doing. And I'm not sure right now which one gets applied first. We could say lower gets applied first to line, so it makes everything lowercase in here, and then starts with so we can determine actually which one. So if we do starts with H, so let's run this. So it says true, right? Print this, and the answer is true. So this gives us either true or false. Does it start with H or not? And this must have gone first, so that everything is lowercase, and then we said, does it start with H? We got true. If this had been applied first, then it wouldn't have started with H, so we would have had false, and then I don't know what would happen if you did false and then applied lower to that. I think you'd probably get an error. But anyway, it doesn't work that way. This one is applied first, and then this one. Okay, this says fix the following function, so we're defining a function here. It should use the string method count. So this is not a method, right? It's just a function, it's not a method. So we have to somehow change this so that we're using count as a function. I'm sorry, as a method. So we want to apply it to Word, but we want to apply it in the style of a method, the way a method would be applied to Word. And then it also says there are some other errors as well. But the key one is that this is not a method as it's currently written. And in other words, we have to use dot notation. So if count is a method, it would be applied using the dot notation. So you can try and work on this one. Okay, and let's go on to the next section now. So the next section is called Parsing Strings. Now we talked about parsing files before, but now we're talking about parsing a string. Okay, so let's look at this example. So we have a string here, and we're assigning to the variable called data. So data is equal to this string. And then we're using a method find. We know that it's a method. We're using the dot notation. We're applying it to data. So data.find, and we're looking for the @ mark. And this is going to give you the position or the index where the @ mark occurs. So remember, we would start here with the 0th index, the 1st, the 2nd, the 3rd, and so on. And we want to know what's the index for this one. And we're going to assign that to @position or @POS. And that's going to be the index, and we're going to print that. And then we're going to do the same thing again, but this time we're going to find this. This is an empty space here, right? We're going to use data.find, and then this is an empty space, but we're going to start at here. So we're going to start here and look forward to the first empty space. So in other words, we're going to go to here. And that is going to be, and remember, find again is a method, and that is going to be assigned to here, space position, and then we're going to print that, and then we're going to define something called host, which is actually this thing here. This is called the host, I guess, just this stuff here. And the host is we're going to take data, which is this whole string, and then we're going to go from @position, which was where the @ mark was, +1. That's going to start us here at U, and then colon, and go up to space position. Remember, this doesn't include the space position, so we're going to go up to here, but not including here, so we're just going to stop at the A. And that whole thing, that's a slice, called a slice of data. We're slicing data or extracting from data this stuff, this range here, and then we assign that to host, and then we print host. So let's read what they say here. Often we want to look into a string and find a substring. So that's what we want to do. We want to find this substring. For example, if we're presented with a series of lines formatted like this, and we wanted to pull out only the second half of the address, only this part here, which I guess is called the host, from each line, we can do this by using the find method and string slicing. So that's what we did. We used the find method, and then we used this string slicing down here. First, we will find the position of the @ sign in the string, so that's what we did here. Then we will find the position of the first space after the @ sign. Finally, we will use string slicing to extract the portion of the string which we are looking for. Okay, let's go to Chapter 7, Section 11, the format operator. So first of all, remember operator. So remember, we call these operators, at least these first four, we call them operators. So this is the addition operator, the subtraction operator, the multiplication operator, and the division operator. And operator just sort of means that there's typically something on the left side and something on the right side, and then the result. So you put something on the left side, like you put 4, and something on the right side, you put 2, and then, or 3, and then you get, and it gives you a result, and so we get, in this case, we get 7. So that's basically what an operator is. There's something on the left and the right. It doesn't have to be. You can have a one-sided operator, just one thing. For example, the square root is sometimes called an operator, and that only takes one input. So, right, you take the square root of 4, right? And that's not, you don't need two numbers, you just need the square root of a single number, like 4. So, but typically an operator has something on the left and something on the right, and that's called a binary operator. And the same thing with subtraction and multiplication and division. We also learned this one, which we call modulus. So, for example, if we use it here, 10 modulus 3, we get 1. It's the remainder after you divide 10 by 3. So what's left over? So this is also an operator. You have a binary operator. You have something on the left and something on the right, and then you get a result. So these are examples, 5 different examples of operators that we use on numbers, that on things on the left and right are numbers. Now the percentage sign has a different meaning when we're talking about strings, and it's not called a binary, it's not called a modulus operator, it's called a format operator, and it allows us to construct strings, replacing parts of the strings with data stored in variables. So what does that mean? So let's take an example. Okay, now this first example is not too enlightening, but let's just look at it. It doesn't make the concept that clear, but let's still just look at it. So first of all, we start out by defining camels equal to 42. Okay, then we're going to use print, but we're going to print. So actually, what we're going to do is we're going to print camels, but so this is what we're actually going to print. But there's some other stuff here, and in particular, it's this thing that we want to focus on right now. And so it says we're going to print. This means extract from here, or convert this to a, and D stands for decimal. So convert it to a decimal, but then notice we're putting this around it, this and that. So we convert it first to a decimal. It seems like a strange thing to be doing, but just bear with me for a while. So we convert it to a decimal, which it probably already is a decimal when we write it like this, actually. But anyway, we're forcing it to be a decimal, but then we're converting it to a string, basically. And so the result here, we actually can't even see that it is a string, but the result is the string 42. It does have the quotation marks around it, although when we print it out like this, it doesn't show them, unfortunately. So as I said, this is not such a great example. So let's practice some more. Maybe we'll get past this example. Okay, so now we can take a whole string. So you can see I have spotted, and then this thing, camels. Now this thing has a special meaning. So it's not going to be just like a regular part of the string. So like we're not going to print out just what's here. This is not what we're going to see. So what we are going to see is this thing will look for the first string over here, and or the first variable over here, and it will apply this format operator to it, which means it will try to convert it to a decimal. So it's going to take this, try to convert it to a decimal, and put it here. Well, we already saw that when we convert this to a decimal, it's going to be the number 42. And actually, what we saw before was that maybe it was the number 42, but then it got converted to a string. But now it's just going to convert it to a number, the number 42. Maybe it doesn't even need to be converted because I think it's already a number, but this is just kind of enforcing the fact that it's going to be number. and it's extracting from here something, and in particular, it's extracting um, the numeric form of this, if we might say that. Okay, so what this is going to print out is I have spotted, and then this is 42, and it's going to print in here 42. So this is kind of like a variable that refers to what's over here. And in the next example, we'll have several different of these kind of variables that will refer to this, and then the next one, and the next one. There'll be several different variable names over here. So you'll see that here, actually, here. So here, this is like a variable, and this works on this variable here, and then here's another kind of one of these variables, and that works on this one, and then here's another kind of one of these variables, and that works on this one with the string with the quotes around it. So what's this one going to do? And then this works on this and converts it to a number, because this is D for decimal. So it's going to say in 3 years I have spotted now G to format a floating point number. And he says, why does G stand for floating point? Don't ask why. But anyway, it stands for floating point. So this is going to work on this one. This is the second of these format strings here. Will work on the second in this thing over here on the right. So there's 1, 2, 3 of these things over here in here. And then this one will work on camels, and that converts it to a string, which it's already a string. So so what will we have in D? And the D works on this and converts this to a number, to a decimal. So it's going to be in 3 years I have spotted, and then this is going to be a floating point 0.1. Actually, this, he said decimal, but I think it's integer. So this converts this to an integer, which it already is, and then this converts this to a floating point, which it already is, and then this picks up this and converts it to a string, which it already is. So in 3 years, I have spotted 0.1, is that right? Maybe, camels. Let's try this and see. Yeah. Okay, let's quickly review this this word called tuples. So when we have two things in parentheses like this, we call them an ordered pair. Like you might have 4, 5, and that's called an ordered pair. And usually we think of that as a point in the plane. So we have like, 4 might be here, and 5 might be here. 4 might be here, and 5 might be here. And of course then this point, this ordered pair, could be associated with the point right here. Right? Something like that. Right? So, but anyway, this is just called an ordered pair, whether you think of it as a point or not. And this is called an ordered triple, because there's 3 of them. And this could be called an ordered quadruple, because there's 4 of them, and then maybe we could have 5 of them and call them something else. But in general, we'll just call them tuples. So these are all tuples. So you could have 2 in a tuple, you could have 3 in a tuple, you could have 4, you could have 5, you could have 100, whatever you have. And a tuple is just, parentheses and some commas, so like this one has 3 commas, and then stuff in between the commas. That's called a tuple. So that's called a tuple. So here he says, if there's more than one format sequence in the string, so in this case, in other words, here we have this format string and this format string. These are called format sequences. Format sequence, format sequence, format sequence, format sequence. There's 3 of them. Then over here you have to have some tuple, which is what we had. Remember, we have a bracket here and bracket here, and we have 2 commas, so we have 3 items. So that's a tuple. So we need to have 3, an ordered triple. because there's 3 of these here, these format strings, also sometimes called format operators. So he says the number of elements in the tuple must match the number of format sequences. So here they don't match, because here I have 3 format sequences and I have 2, like I just have an ordered pair here, or 2 elements in the tuple. So we get an error, type error, not enough arguments for the format string. So the format strings, there's 3 of them, but there's only 2 here. And then also they have to match the number of format sequences in the string, and they must also match the format sequences. So this won't work because dollars is a string, and we're trying to convert it first to a decimal, and then we're going to make it a string. But converting it first to a decimal doesn't work. So we get a number is required here. This is not a number. This is a string. Okay, let's go on. Okay, let's move to debugging 7.12. So let's look at this example. So it says while true, and then so this is going to repeat over and over again unless somehow we can break out of this loop. And the only way we can break out is if we get to this here. So there's one other thing that could happen, and that is continue here. So anyway, we start with we have the input. We ask for input, and we show a prompt here, and then and the input gets assigned to this variable, and we check the first element in this string, and if it's equal to the hash mark, then we skip up to ask for a new. We ask for a new input, which is basically just a new prompt here. So we show a new prompt, and then the user will respond somehow. So again, if they type in the hash mark, then it'll just break out of the loop and come back up here again and show this again. If we don't show a hash mark, and if we don't type done, then we'll just print whatever the user entered up here. And the only time that we're actually going to get out of this loop is if the user prints done. So let's check it out. So here it is, and I'll run it. I already saved it, so I'll run it. So it doesn't show us this typical Python prompt. It shows us this, which is what we designed it to show. Right? Let's just check that. Oops. We designed it to show a single arrow here, or angle bar here. We could have put anything in here, and that would have shown up here. Anyway, this is what shows up. So if we type something like hello there, and it prints that, because this is what it says. It prints the line that we input. And if we type in something else, it's going to print that. If we print hello there again, it's going to print that. And if we hit the hashtag, then it's just going to go back up to the top of the loop again, and it'll ask again for some new input. And if doesn't matter what we put after the hash mark, because it's only checking the first element of the string that we type in. So if I type in something else here, like ignore, or don't ignore this, it'll still just do the same thing. It'll just give us a new angle bar here. So the only way we can get out of this is if we print done. But notice, by the way, whenever we put a hash mark, it doesn't respond with a hash mark or anything else. It's just a blank. But if we type anything else, it will just repeat what we type, hello. But anyway, if we type done, I think it's done like this, then that's the only time it will get out of the loop. That's the only time it will break out of the loop and then print not what we typed, which was done, but we'll print this. So let's see that. So that is the program. And now we're out of that loop, we're out of the program. And we can run it again. So this section is about debugging. So we see how the program works, and we might think, oh, this works pretty well. But he says that there may be parts of it that we haven't thought of yet, or some situations that we haven't thought of yet. For example, what will happen if the user just hits the return key, in other words, just enters a blank line. So I guess then it's going to attempt to print that blank line, and I guess that causes an error. So let's try that here. We're not going to enter anything, we're just going to hit the enter key. So we get this kind of error. So we're asking for the first character, but there's not even a first character in what's being entered, and that causes a problem. So we're referring to a first character in the string, but the string is blank, and so, or empty, and so asking for the first character causes a problem. Python doesn't understand that, I guess. So he says the code works fine until it is presented with an empty line. In that case, there is no 0th character, so we get a traceback error. There are two solutions to make line 3 safe, even if it's empty. So we want to fix this somehow. So I guess this works. Starts with, this is not referring to the 0th character. It's doing something else, and this doesn't cause an error. Then he says another way to get around this safely is to write an if statement. So preface this part here, which was causing the error when we entered just a blank line, because this refers to the 0th item of that, or the 0th indexed item of that, which doesn't exist. Only apply this, or only give us that continue if the length of the line is greater than 0 and they type in the hash mark. Okay, that's the end of the debugging. And that's the end of the discussion for chapter 7.